Let's take a look at a polynomial in factored form. So to determine the degree of this polynomial, all you need to do is add the exponents of each of these binomials. So I have a degree here of 2, plus a degree here of 5, plus a degree here of 1. If you don't see an exponent, remember there's an exponent of 1. 2 plus 5 plus 1 is 8. So that means 8 is even. So my end behavior is even. And notice there's no negatives in front of the x's. There's nothing here. If you would multiply this out, it would be positive. So this is even positive. And now let's recall what that means. So if a function is positive, you will always have something going in the upper right corner. If it is even, your function is going to go in the same direction. So as x approaches positive infinity, my y values are going up. They are approaching positive infinity. As x approaches negative infinity, so we go this way, y is still going up, so it's approaching positive infinity. Now let's take a look at finding the zeros of this graph and discussing the multiplicity of the graph. So here, if I just take what's in parentheses, you can see to make this 0, x equals -5. Oops. And again, if you think about it, if you put -5 in here, -5 plus 5 is 0. And also look at it, just take your number, change the sign. Now, multiplicity. Multiplicity is the number of times a 0 appears. Well, you can always look at the degree there to determine how many times this degree is going to appear. The degree here is 2, therefore the multiplicity is 2. Now we look to determine, is the multiplicity even or odd? 2 is an even number. And so if your multiplicity is even, it does a touch and turn on the graph. It's going to touch the x-axis and then it'll turn around. Here on x minus 1, your 0 is x equals 1. Your multiplicity is 5. 5 is an odd number. So if your multiplicity is odd, it's going to cross the x-axis. It goes right through the x-axis. And here, x plus 7 equals 0. Well, that means x equals -7. My multiplicity, it's a degree 1. 1 is an odd number. So when x is -7, the graph is going to cross the x-axis. Now let's sketch this graph. Graphs do not need to be precise. So let's start out. Our end behavior we determined was even positive, which is up and up. Let's put in our zeros. I have 1 at -5. I have 1 at +1. Oh, looks like I need to, let me rescale this. I've got a -7. Let me get this as -7, -5, and we'll put, I got a +1. Okay, so let's just work, we can work left to right. So when x is -7, my graph has to cross the x-axis. So it's going to come down, it's going to go through it. When x is -5, it's going to do a touch and turn. So that means it's going to come down, it's going to come back up, hit -5, and then it's going to come back down. Now at x is 1, it's odd, so it's going to cross. So somewhere, it doesn't matter where you put it on your graph, we're just doing a rough sketch. So somewhere it's going to turn back around, it has to cross through 1, and it'll meet your end behavior. This by no means is going to be a precise graph, What's important here is that we recognize the end behavior. We recognize the behavior of the graph at the zeros of the function. So let's take a look at transformations. So your parent function here, this is a cubic, so your parent function is going to be x to the third power. Now, any function is a transformation of the parent function, and this is the same thing we learned in topic 2 with quadratics. We might just have a little bit, I think in topic 2 you saw an h here and a k there. They do the same thing. Your n is just whatever exponent you have. This is going to apply to any function, whether it's a quadratic, a cubic, quartic, quintic, etc. So your whatever value here is next to your x, that's going to be a horizontal shift. And remember, you kind of have to think opposite of what the sign is. If this is negative, you're moving right. If it's positive, you'd be moving left. Whatever is hanging out over here with either a plus or a minus, that's your vertical shift. That's going to be up and down. If it's positive, it's up. If it's negative, it's down. Your a value, if it is greater than 1, exclude. If you see a negative there, don't even worry about it. Look at the number, not the sign. If it is greater than 1, it's going to be a vertical stretch. If it is a proper fraction or a decimal, it would be a compression. If you see negative out front, that is a reflection across the x-axis. So now let's take a look at what we've got here. Here, right off the bat, there's a negative. This is reflected across the x-axis. Here, I have 1/2. That's another a value. That's a compression. This is a vertical compression by 1/2. And again, you can think this is multiplication. So if you even just think about it, if you're multiplying something by 1/2, or if you're multiplying something by a decimal, well, you're making it smaller. You're compressing it. If this would have been, say, a 2, well, if you multiply something by 2, aren't you making it bigger? You're stretching it. So now let's take a look inside these parentheses. Okay, that's a horizontal shift. And again, if it's positive, that means you are going left. Think opposite. Horizontal shift left 5. And then if we look here, -6, that means this is a vertical shift down 6.